Have you ever really stopped to think about what happens in those few milliseconds after you type a URL and smack the enter key? It feels so instant, right? But behind that one single key press is this absolutely incredible high-speed journey that spans the entire globe. Today, we're going to follow that journey, step by step. It all kicks off with a simple string of text, just like this. But this isn't just an address. It's actually a set of instructions that triggers a super complex sequence of events. Think of it like a digital relay race between your computer, servers, and all this infrastructure all over the world. All right, so here is the roadmap for our little request. First, we'll find the server's location. Then we'll make a secure connection, ask for the page, build it from the code up, and finally, bring it to life. We'll even take a quick look at a few different kinds of document object models at the end. Okay, first stop. Let's see how the browser actually finds its destination. See, your computer doesn't get what example.com means. It only speaks in numbers. So the very first challenge is translation. This whole translation thing is handled by the domain name system, or DNS. The easiest way to think of it is as a massive distributed address book for the entire internet. Its one and only job is to look up a name that we humans can read and return the correct numerical IP address that machines can understand. Now, to be super efficient, your computer doesn't ask for directions every single time. First, it checks its own memory, its cache, at a bunch of different levels, in the browser itself, in the operating system, even on your router. If it can't find the address locally, then the request goes out to your internet service provider, which kicks off this big hierarchical search, all the way from the root of the internet down to the one server that knows the answer. And there are basically two ways this search can go down. With a recursive query, which is what usually happens on your end, you're pretty much telling your ISP's resolver, hey, you do all the legwork and just get back to me with a final answer. But with an iterative query, the resolver would say, I don't know, but go ask this next server, and you'd have to keep chasing the answer down the line yourself. So now we have the server's numerical address, but we can't just start shouting requests at it. The browser needs to do a formal introduction, and for pretty much any modern website, set up a secure, private line of communication. This whole thing starts with what's called the TCP three-way handshake. It's kind of like a very polite, formal greeting. Your computer, the client, sends a SYN packet saying, hello, I'd like to connect. The server replies with a SYN ACK, which means, hello, I got your request and I'd like to connect too. And finally, your computer sends one last ACK, and boom, the connection is officially open and reliable. But wait, we're not done yet. For a secure HTTPS connection, we need another handshake, the TLS handshake. This is where the client and server negotiate which encryption methods to use. The server presents its SSL certificate, think of it like a digital ID card, to prove it's the real deal. Once that's verified, they securely agree on a secret key to encrypt everything they're about to say to each other. This whole process has a huge impact on speed. Each one of these back-and-forth handshakes is a round trip that adds delay. Now, older protocols like TLS 1.2 needed more trips, but modern standards like TLS 1.3 have really streamlined the process. By cutting down those round trips, they can give you a real, tangible speed boost of 20% or more just to get that very first byte of data. Okay, so we've got the address, and we have a secure, private connection. It's only now that the browser can finally ask for what we actually came for, the web page itself. And this is the moment. The browser sends what's called an HTTP GET request. It's really just a simple, direct command. Get me the content at this address. This first request is almost always for the main HTML file, which is basically the blueprint for the entire page. The request isn't just that one command, though. It also includes a bunch of headers that have extra info, like what browser you're using, what kinds of content it can handle, and any relevant cookies from past visits. It's all the context the server needs to give you the right response. So the server gets this request, it processes it, which could mean running some code or hitting a database, and then it starts sending the HTML file back. The time it takes for that very first little piece of data to get back to you is a super critical performance metric called time to first byte, or TTFB. All right, now the browser has the raw material, the HTML code. But a bunch of code isn't a web page, right? Let's see how the browser turns that blueprint into an actual visual structure. This whole process is called the critical rendering path. As the browser gets the HTML, it starts building this internal map of the page's content and structure. That's called the Document Object Model, or DOM.
At the very same time, it starts going through the CSS to create a similar map just for styles, the CSS object model. Then it combines those two to create the render tree, which is the complete plan of what to display and how it should all look. Now, to speed all this up, browsers have a really clever trick up their sleeve. While the main parser is busy building that DOM, a second, lighter-weight thing called a preload scanner races ahead through the HTML. It's literally hunting for important stuff like style sheets, scripts, or images, and starts downloading them in the background. That way, they're ready and waiting when the main parser actually needs them. Pretty smart, huh? So we have the structural plan from the render tree. Now it's time to actually draw the page on the screen and, make it do stuff. First up is the layout step. This is where the browser does all the math to figure out the exact size and position of every single element on the page. Next comes paint, where the browser literally fills in the pixels, drawing the text, the colors, the images, all onto different layers. And finally, in the compositing step, it takes all those layers and assembles them into the final image that you see on your screen. So here's the crucial thing. Just seeing the page isn't the end of the story. A page can look totally loaded but be completely unresponsive if its main computer brain, the main thread, is busy running a bunch of JavaScript. That's where time to interactive, or TTI, comes in. It measures when the page is not only visible, but is also ready to respond to your clicks and scrolls almost instantly. Before we wrap up, let's quickly zoom in on that term we've been throwing around, the DOM. It actually has a couple of really important relatives that are key to how the modern web works, the shadow DOM and the virtual DOM. Okay, the key difference here is what they're for. The shadow DOM is a browser technology. It's for encapsulation. It lets you create these self-contained components where the styles and behaviors don't leak out and mess with the rest of the page. The virtual DOM, though, that's a totally different concept used by libraries like React. It's a lightweight copy of the real DOM that's used to figure out the most efficient way to make updates, which gives you a huge performance boost. And there you have it. In just a couple of seconds, the browser has played the part of a translator, a security guard, an architect, and an artist. It took a name we can read and turned it into an address for a machine, established a secure connection, requested and parsed the blueprints, built a whole structural model, and then finally painted an interactive web page right onto your screen. All of that happens every single time you press enter. It is an incredible feat of engineering. And look, understanding these steps isn't just for fun. It's the key to figuring out what's wrong, making things faster, and just building better stuff on the web. So the question is, now that you see the whole journey, which step are you going to focus on optimizing next?